Welcome to another episode and video on my Raspberry Pi 1, which is connected through band cable to this breadboard with electronics and some fischertechnik. Let's take a look at the Raspberry Pi, which is right here. And Raspberry Pi 1 runs Raspbian Linux, which is specifically created for the Raspberry Pi. Stacked upon it is a Serial Pi Plus with a serial cable, which is connected by such a converter cable to a computer with a Minicom serial terminal. Then also connected to with a network cable to a local network, and a Raspberry Pi camera for streaming video. In this case I can take high resolution pictures, high resolution video, but I'll come to that later. Connected as well is, well, inserted is a micro SD card for hard disk storage, for which it boots the Raspbian Linux. Then as said, this band cable, which is in fact actually GPIO, general input output, general purpose input output. And right now I am focused on this part of the whole board. This one is a different experiment. Connected or stacked on the board is an MCP 23008 chip, which is I2C extension. That means that the yellow wire and the brown wire are I2C data and clock, controlling these LEDs. Also this LED, which is fischertechnik, and this LED, which is also fischertechnik, but a different one, and a switch. And last time I changed the algorithm to have the switch control the way the binary counter is dealt with, and that should have been working, but I just see that one of the wires is off, so let me try to fix it on the fly. Although it doesn't really matter because the current algorithm, oh, that is not good, whatever happens here. Anyway, this wire doesn't really matter because I restricted the algorithm to the first 3 LEDs. But it may come back later again. Let's first try to see if this connection, which is power, ground, and under it, as said, the data and clock line, are actually working. So, starting the algorithm, and then it helps if you do it the right way using sudo, and of course everything works except that I don't see anything. So probably, most likely, something here is wrong again. Now they work. So the clock line was indeed, am I saying that right? No, the data line was faulty. Anyway, now you see how it works, or should work anyway. Yep, and then if I press the button, something else should happen. And that was the last thing that I did last time. Being curious if the status that I was left with was really due to my programming or something electronically. So let's take a further look at the software and oscilloscope, etc. So right now this is nicely working. I will adjust the time base a bit. That is because every thing you see is constructed from various signals. Right, this should be it. No, it's not. The nice signal that I used to have is more like this. No. And now for some reason it seems hard to get the nice signal that I used to have. Okay, let it be for a moment. I'll get to that later. Not strictly necessary, but you see that there is a signal on the oscilloscope, so that's good. Then, of course, what you have seen already is the whole setup running nicely. It's a binary counter. So the first LED is 1 or 0, the second LED is making up 2 and in combination with the first 3. So that works nicely. Then also streaming. This is with a delay. Why is this with delay? Because when I hold my hand in front of it, you can see it first here and then here. So that is how many seconds delay there is. Also, now I take my hand away, 1, 2, 3, etc. 4 seconds delay. Another thing is that this screen is now very small. It used to be screen filling. I didn't change any of the properties, and yet it is like yeah, always fit window. If I go full screen, what does it do? Okay, that may be it. If I enlarge this, what happens? You get the black bar. Okay, let's keep it that way. Alright, so this is what you get. Then it is time to actually press the button. After I see something happen, of course, which I don't. And unfortunately not for the first time. Keep in mind that things don't touch. Now they work again. And here used to be a red LED, but that red LED didn't shine the way I like. So I remove that one, and let's press the button, see if that makes sense. 5. No, it doesn't count back. It keeps. Now it makes sense. So it counts to 5. 1, 2, 3, 4, 5, 6, 7. Letting it go. And 5, 4, 3, no, 5, that's not correct. 7, 6, 5, 4, 3, 2, 1. Yes, so it does count back. 7, 6, 5, 4, 3, 2, and 1. Now press the button again. 1, 2, 3, 4, 5, 6, 7 in a very high speed. So this means that it actually works. But last time I tried to introduce a status like here, a switch status, to see whether it would mind if I release the switch intermediately. But I think when I release the switch, it immediately goes back to where it was, but I have to test it, of course. So actually it does work, although the speed I don't like. So it one thing is much faster than the other. This is a delay of 250. Oh right, and here I have a delay of 1.5. Wait. If I change this to 1.5 seconds, or more appropriately 1 1.25 second, whatever, 1/8 second actually. Okay, that will be the whole problem. So now I need to compile. Is done. Interrupt. And now the speeds will be the same. And I have to show something different, something else as well. Right. So this kind of works. Let's check it once more. Starting. And then yeah, okay, so this is counting down. 7, 6, 5, 4, 3, 2, and 1. Then I press the button, and you see here that the 3 colored LED is burning. 6, 7, and again 0, 1, 2, 3, 4, 5, 6, and 7 in binary. So that works nicely. If I look at, well, another thing, this is virtual network computing. You see here the window of in which I compile. Here is the window in which I show every print result. A bit overflow of information, but if you have watched the whole development of this experiment, you know why. Then a tab, this tab actually, for the VLC, this streaming video, and of course this one for, in this case, the RaspberryPi source code. Well, not the source code of the RaspberryPi, but I hope you know what I mean. There's something else as well, like I said, and let me show you right on this camera. Yeah. So right now I also have the VLC on my iPad. And this shows only part of the screen, as you can see, but I should be able to scroll, and I actually can scroll. If I do it like this. So there you have the full extent of VLC viewer on my iPad, and that's a very nice thing to do. Too bad I can't do it on Android. My Android is getting too old for a lot of applications, but this is a very nice thing to have. Desktop is much nicer because I can see everything at once. And can I adjust the resolution on the iPad? I don't know yet. Okay, then next, what happens, going back here, no, here. What happens when I release the switch intermediately? So, alright. So now it is going to add 3, release 4, 5, 6, 7. 6, 5, 4, 3, 2, 1, 0. 1, 5. Okay, so now I press the switch. Okay, so this shows, and if you have noticed, the LED doesn't start to burn until a routine has been finished. So I release the switch. Okay, 7, and then again it starts to count down, and it keeps counting down, and now it starts to burn and count upwards to 7. So this shows that a routine like here, like this one or like this one, is not being interrupted when I press the switch. It does read the switch, but it just keeps going. And actually I should reduce the number of print lines in here to show it. And that will be interesting to see how it actually processes the button switch while in counting. Alright, so let's go. Yeah, the switch status is something I need. This I don't use anymore, but I'll just comment it out. You will reduce the output considerably. And the same thing I will do here. Button pressed is going to be there. This one I'll take out. All not necessary strictly. Right, so that is one. And now it has switch status, print switch status, which is good. So now I will see how it is being dealt with. Although, yeah, here switch status is 0 and here it is 1, equal to the button being pressed or not. Right, compile. Yep, correct. Now I have to cancel this one and start a new version. Oh wait, the inside. Oh, that's really? Where do I have a switch status 2? This is switch status is 1. This is switch status is 0. Where do I have a switch status 2? Because here I assign it to being 0. Surprise, surprise. Not pressed, which is here. Then I say here switch status is 0. Interesting. So what happens when I press the switch? Oh, now that is interesting. The button, the switch status stays 2. Really? That is not the purpose of a status, needless to say. But where does it got its status 2? This is 1. I don't even say plus or minus, just switch status is 1. Right, let me do it in another way. So I can also do it differently, that I get this outside the main, but that is not strictly necessary, logical, but okay, let me do something else. Switch status. First, assignment is %d/n switch status. Now, oh, that's what you get if you don't press escape in between. But let's go here. Oh wait. Yeah, right. Here I forget something. Switch status. And here I should print switch status if I'm correct. Alright. Quit. Compile. And you notice now that although syntactically correct, the program didn't do what I wanted. See. And now it more or less does what I need. Now I press 1. And now you've noticed that between me pressing the button, it actually getting the status and actually getting on, there is some time involved. So it is happily counting, as you can see from here. Now I release the switch. And now it gets it and goes to 0. So it indeed just keeps the status as it is until the countdown or count up has been finished. And yes, in C, this is the way how you insert a value into a print statement, and then you do have to put the actual variable behind it. Otherwise it just takes on some value. In this case it was 2. It could have been any other thing. So that does work. And then I notice that I am actually going over time once again. Exciting stuff. So why this is not the way I expect it to be, I don't know. can see it count if you take a close look. Right here, and wait for 4 seconds right here. Yeah, this is counting down, but I'm afraid it's not very clear to see. And I showed you on the iPad how you can see part of the video, part of the VLC, of the VNC, and play with it. So once again, the end of an episode with some nice stuff. So correcting the algorithm for showing the switch status, finding that it has some delay, an irritating change again with a VLC for the live stream from this, the point of the Raspberry Pi, and VLC viewer, VNC viewer on an iPad. Thanks for watching. If you like this video, please subscribe to my channel, give the video a thumbs up, leave a comment or suggestion. You can also follow me via Instagram and via Twitter. And also you're welcome to give a donation in support if you like this what I do. You can support me via PayPal and via Wired. Also, if you become a patron, you can have your, well, if you want to have your name mentioned as a supporter, you can become a patron, and more information about everything is under this video, including the website of my, the URL of my website. Mixing up things, not good. Anyway, thanks for watching, to be continued, and bye bye.